This video is going to discuss Fermi questions or Fermi problems in general, briefly, and then do a specific example on the number of gallons of blood pumped by a human heart in a lifetime. So first, the Fermi question or Fermi problem. It is a question that asks for just an approximate answer. The true or correct answer is generally not known. To solve this or get a value for the Fermi question, a working principle is to break the problem down into many factors, make an educated guess and a guess for each factor. Hopefully some of your guesses will be high, some will be low. More information about Enrico Fermi and Fermi Problems is available on Wikipedia, so please take advantage of that. So in this video, we're going to estimate the number of gallons of blood pumped by a human heart during a lifetime. And I'm going to try to show all the steps I did in this calculation. This is not the only way to do the problem. But I started by saying, well, to get a number of gallons, perhaps I can estimate the number of heartbeats in a human lifetime, and then estimate how many heartbeats it would take to fill up a gallon jug. That's the way I imagined it. So a milk jug of a gallon. And I tried to figure out or guess how many heart chambers would fit in a gallon container. My guess was 5 by 5 on one layer on the top, and then 8 layers vertically. So the number of heart chambers, and thus heartbeats, for 1 gallon would be 5 times 5 times 8. That would be 200. Well, we have part of the answer. Now, how do we estimate how many heartbeats a person will have in a lifetime? And we'll take an average life. And my guess is in today's society, in the United States, the average life would be 80 years. Oh, 80 years per life, 365 days per year, 24 hours per day, 60 minutes in an hour, and guessing 65 beats per minute. Now, so some of these pieces are guesses, some are closer to reality. So calculating the number of beats, I set up here a series of conversions. So 80 years per life, 365 days in a year. So now the years units are going to cancel here. And then 24 hours in a day, the day units will cancel. 60 minutes an hour, the hours units will cancel. And 65 beats per minute, the minutes unit will cancel. And we have left that's not canceled, beats per life. And I'm not bothering to get real accurate on the number of days per year. This is an estimate. So it's not worth my time to punch in 365.25 into my calculator. I'll just punch in 365. So in doing that, I come up with 2.7 billion heartbeats in a lifetime of 80 years. 2.7 times 10 to the ninth. 10 to the ninth is a billion. Well, now we have this first factor, how many beats there are going to be. Previously, I estimated how many beats it takes to fill up a gallon jug. So dividing the 2.7 times 10 to the ninth by 200, I came up 1.35 times 10 to the seventh, or 13.5 times 10 to the sixth. I've moved the decimal place once here, make it 13.5 and reduce the power of 10 by 1. 13.5, 10 to the 6th, and it's time to round off a little bit more. So 14 million gallons is my estimate for the number of gallons of blood pumped by a heart. Well, just for fun, I went to the internet, and there's not total agreement on the internet. So ChatGPT gave me 63 million gallons. This was done on July 7th. Quora website, 48 million gallons. Copilot, Microsoft Copilot, 42 million gallons. The Google AI said 51 million gallons for 70 years. The Cleveland Medical Clinic, very well respected location, 58 million gallons for 79 years was their estimate. WebMD website, 58 million gallons for 80 years. And there was a physics textbook that had this problem in it, and they estimated 400 million gallons. Well, in doing this Fermi question, I might think a little bit, what's the weak link in all these factors that I guessed, and I think it's probably the 200 beats being 1 gallon. I'm not a medical specialist, and I did not look up measurements for a heart chamber. But if I changed it to 50 beats per gallon, this would up my result by a factor of 4, so roughly 56 million gallons pumped in a lifetime. But the point of the Fermi question is not to get the right answer. We don't know what the right answer is. It's to get an approximate answer, to get a sense, a feeling for the problem. This can be useful in physics work, and that you can roughly estimate what your answer is going to be before you do a calculation. This may prevent you from making major mistakes as you work physics problems. Well, I've got a number of YouTube videos. They're annotated. They're listed at my website, gpclements.com, and everything there is free. You do not register. You do not give me your email address or your name or anything else. It's all free. I don't put cookies on your website or on your computer from my website. I hope you enjoy the videos and keep practicing your own Fermi questions.